Hi, everybody, and welcome for joining us today for our presentation, Why Solar is a Smart Choice for Farms. My name is Riley, and I'm joined today by project developer Andrew Stetter from Straight Up Solar. We're very excited to take you through this presentation. So let's get started. To introduce myself, my name is Riley Francis. I'm a marketing coordinator here at Straight Up Solar. I've been working on the Straight Up Solar team since the year 2018, and I enjoy working for Straight Up Solar because it lets me do work that is both good for people and good for the environment. And today I'm joined by Andrew Stetter, one of our solar project developers here. Andrew is very passionate about helping people go solar. He's developed over 170 individual solar projects in Illinois, spanning residential, agricultural, commercial, and nonprofit projects. The Straight Up Solar vision is to care for others by creating a path for clean, renewable energy and a sustainable economy that honors our values and everyone's healthy, shared future. The Straight Up Solar clear values are community first, lead the solar tribe, educate the solar lesson, advocate for smart solar policy, respect for people and planet, and excellence in all we do. Straight Up Solar is a certified B Corporation, and what that means is that we take a look at the sustainability of our business, not just our financial sustainability, but also our environmental and our social sustainability. And we strive to make our business the best it can be for people and planet. So to be a certified B Corporation, we report and we track our sustainability efforts, and we must score a certain score on this report to be considered a certified B Corporation. And we're very proud to be a certified B Corp. A little bit more about Straight Up Solar. We were founded in 2006 and we serve Illinois and Missouri. We have over 1,700 projects to date. We're a part of the Amicus Solar Cooperative. Again, we're a certified B Corporation. We have over 75 employees, with almost half of those having their North American Board of Certified Energy Practitioner certification. We're a Tesla Powerwall certified installer. We're now offering some new products. We're offering the Generac Power Cell battery and the Enphase Encharge battery. We're an REC Premium solar installer, and we have a 10-year workmanship warranty. All right, the topics that we're going to cover today are: how does solar work? Is solar right for my farm? What are the benefits of solar? What does an installation look like? What are the financials and incentives? You'll hear a testimonial from one of your neighbors, and then we'll get into how you can get started on your own solar project. So now at this point, I'll turn it over to our presenter for today, Andrew Stetter. He'll go ahead and introduce himself in a little bit more detail, and he'll take us through the rest of the presentation.
Thank you, Riley. I appreciate the introduction. Hello, everybody. Thank you for joining today's webinar. As Riley has mentioned, my name is Andrew Stetter. I've been working as a project developer for Straight Up Solar for the last 4 years or so. I started my solar journey by going to Illinois State University to get my bachelor's degree in renewable energy with a minor focus in construction management. I really enjoy working for this company. It's great to help people with their own solar journey. You can see in the pin map that I've helped a lot of people. Those are all pins from projects of mine across the state. And hopefully today I can impart some of my knowledge and experience on you and help you have a better understanding of what this might look like for your property. So how does solar work? Just like any other form of energy, solar is able to be transformed to another type of energy. So what a solar cell is actually doing is taking the energy from electromagnetic waves and converting that into a current or a flow of electrons. It's basically doing that by taking silicon cells, which are stable together. They all have 4 valence electrons, so they form covalent bonds of 8 on their outer shell, which is a very stable bond. Silicon in the cell is actually doped with parts per million, typically of phosphorus and boron on either side. Boron has 3 valence electrons, phosphorus has 5. And essentially what this does is it creates an imbalance or a positive and negative charge on the PN junction. And when the light strikes the silicon cell or the photovoltaic cell, essentially, if it strikes it with enough energy, it knocks a free electron over to the other side through the PN junction, creating an electric current. So we will keep on going. This slide is kind of the last technical slide about solar, but we wanted to kind of demonstrate what electromagnetic wave looks like. So you can see that over there on the left. In the middle of the electromagnetic spectrum, there's a very small bandwidth for visible light, which is the main energy bandwidth that is actually being converted into electricity for single junction cells. There are multi-junction cells that exist for applications in space. But for the average solar panel for a home or a business, it's going to be a single junction cell converting visible light into electric current. Couple other fun facts about light and PV systems is that light actually travels at almost 300 million meters per second. So speed of light is very fast, as you all know. It actually exists as both a particle and a wave, which is interesting. We can talk about that more later if you're interested. And I think that'll be it for this slide. We'll keep going. So what are the main components of your solar array? Obviously, there are the modules or the solar panels. Those are going to be up on the roof, typically. Sometimes they'll be on the ground. A lot of times for rural applications, farmers have a lot of land and ground might make the most sense. It ultimately kind of comes down to your preference, the sizing that you need or the space that you need to fit an adequate system, as well as building age, direction, tilt, all that kind of stuff. So in this example, you can see the modules up on the roof. Those are going to be generating direct current, which flows in one direction. It is a flat wave. If you were to measure it on an oscilloscope, what we actually use is alternating current, which is oscillating. It's going into back and forth in direction 50 to 60 times a second. So to take that DC power and turn it into AC power, we need an inverter. So that is the next component in the system. Sometimes there's a central unit. Sometimes there is aggregate inverters, one per panel. It really depends, again, on the site and the voltage, the shading, all that kind of stuff. In this example, there's a central unit on the outside of the building. Often it will be either on the outside of the building, on the inside of a building, perhaps on a farm panel or an additional H-frame of some sort. And ultimately from the inverter, that is going to output the usable alternating current, which is power that can be fed directly into your operation. In America, electricity from solar arrays is fed into the actual service itself. That's either going to go directly into the load center or the main electric panel, or sometimes in between the main breaker and the utility meter, which is called a supply side connection. But either way, the electrons that are flowing from this system will go into your loads first. Excess energy, which can exist, say, for example, you're producing 20 kilowatts of solar from a pretty large system and your farm is only using 10 kilowatts of power at that moment in time. For a simple example, the 10 kilowatts of load that you have would get covered by the solar in that moment of time, and the excess power would go out onto the grid. So that is a good segue into net metering. A lot of utilities have different net metering policies. A net metering is basically the ability to send that excess energy out onto the grid for some sort of credit. Certain utilities will allow you to accumulate one-to-one kilowatt hour credits that apply against your supply, delivery, and taxes. Sometimes those credits will last for a month. Sometimes they'll last for a quarter. Sometimes they'll last to the end of the year. Other times The excess energy is all sold at a wholesale rate. And again, that all depends on what utility you're with and the time that you actually interconnect with them, because some of those policies can change over time. Ultimately, working with a project developer like myself, will be able to kind of guide you and inform you as to what the policies are and how those might impact you. We can do our best to optimize the system design to take in the rules into account, to do our best to kind of make the financials as good as possible for you for the investment. So ultimately, solar is beneficial in a lot of different ways. You don't have any emissions coming off of your roof. So it is a cleaner source of energy than the incumbent fossil fuels that our grid largely still is connected to. So there's environmental benefit, financial benefits from this investment through net metering, other incentives that we'll talk about later. And peace of mind, ultimately, that this investment is a safe asset and that it will retain its value in the future. As long as the sun keeps on rising and you continue to need electricity for your home and or business, then this should retain its value fairly well. The modules that we use all come with a 25-year product warranty, an additional 25-year power output warranty as well. There's also there's varying ranges on warranties for the inverters, anywhere from 5 to 25 years, depending on the brand and the type. So it's fairly maintenance free. It's a fixed system, so there's no moving parts. Aside from inverter replacement, it's very little maintenance and very little cost down the road. So is solar right for your farm? It will statistically be right for some of the people in this group who are watching today, and it will statistically not be right for others. Ultimately speaking, solar is going to be more beneficial to certain people than others. And some of that has to do with the site location. Some of it has to do with the utility that you're connected with. So both natural and artificial reasons. But ultimately, if you would like to be able to consume energy that you've made on site by your, with your own system, then it could be right for you. If you want to establish some level of independence from the utility, whether that be partial autonomy or full independence from the grid, which is less common nowadays, it could be right for you. Ultimately, you're somewhat at the whim of the utilities and the regulatory bodies that manage them as to what your electricity is going to cost right now, but also down the road. So whether it be due to inflation or it be due to just an increase in the cost for the utilities to operate the grid, your costs could go up. And there's not much control that you have over that. So solar could be a good way to hedge your bet against rising utility rates. And ultimately, if you're able to save some money, that's awesome, in addition to some of the other benefits we've talked about before. So we'll keep on going. I wanted to give you guys a little bit of an insight into what a solar design looks like and what the process entails. So this is a design from a few years ago for a client of mine. You can see on the left, we're showcasing a design we did in a program called Aurora Solar, which is a program we've used in the past for many systems. Ultimately, you can see an array on the eastern roof plane as well as the southern roof plane. We created that roof design using satellite imagery as well as reference points on the ground from Google Street View. We have both of the arrays are wired in series. You can see the yellow line indicating the actual series connection between the modules. Those little boxes that are kind of at the center of the rectangular solar panels are representing power optimizers, which regulate voltage and current. And then on the kind of western side of the structure, you see that box that says AC/DC. That's not the band, that is the inverter. Both of the series strings of panels are wired in parallel to that inverter, which was at the back of the garage for this client. And then on the right, you can actually see the final design, and it looks very close to the design that we had in Aurora. So I thought that was pretty cool. I also founded the drone division, so I will do a quick plug on that momentarily. Aside from the preliminary design, which is what we just looked at, there's a step in between, the preliminary design and actually installing the system. And that's getting the permits, that's getting the utility approval, that's doing the final measurements and engineering. So that entails the single line diagram, which you can see on the left. Single line diagram literally just means the single line that connects one side of the circuit to the other. So how do the panels get all the way to the meter? How is that all electrically connected? There's all sorts of information like the operational current, the maximum voltage, maximum current. You can see the actual schematic of the systems and labels of all the components. So this is not something you really need to worry about or think about because it's something we handle in-house. And then the detailed site plan is just showcasing the actual physical measurements as measured on site in AutoCAD. So in addition to structural information. So that was a residential example. This is a commercial example. The system on the right was designed in Helioscope, which is another software program we use frequently. And what it's doing is basically allowing us to measure the roof, put a system up on the roof, put inter-row spacing, account for shading from trees, telephone poles, from the modules themselves when there's inter-row spacing involved. So we are able to get a good idea of what can fit on the roof. And then from there, adjust the components that we're using both in quantity, wattage, and type to size the system in such a way that it's going to make the most sense for the owner. On the left, the top left, you can see the schematic that was generated through Helioscope. That's not the final one-line diagram, but just another example of a preliminary one. In the bottom left, you can see a snippet from one of the reports from Helioscope. You can see that actual bar graph showcasing the energy generation month to month based on the location, the efficiency of the equipment, and after all losses, which are shown in that pie chart to the right of it. So you can see in there shading, reflection, soiling, irradiance, temperature, mismatch, clipping, inverters, all sorts of stuff, because there's no perfectly efficient system. So we want to subtract those losses in order to figure out what the net amount of energy you're actually getting from the system, both month to month and also annually. This is a drone shot. It's not taken from a Giant. We flew in the sky with the drone to take a picture of this, and it was the final design. You can notice a little bit of dissimilarity between the preliminary design, mainly that there is a keep out kind of towards that northern edge, and in the northeastern corner, that's where we put the inverters. So, but we wanted to kind of show you the before and the after. So I thought that was pretty cool. There's I think a little bit over 200 solar panels in that design. So I mentioned before, I did start the drone division at the company. I'm really obsessed with technology and also figuring out ways to make our business more efficient and, kind of push the envelope forward. So the drones are able to take very cool videos and pictures of our systems for marketing purposes and just for giving context as to the scale of our installations. But we also use photogrammetry, which is basically the function of using a drone to fly in a few different orbital patterns, meaning around the target object that we're trying to measure in a circular pattern. You see in the bottom left image, there's all those different rectangular they look like TV screens. What those are representing are photos that were taken of a structure at that location, and it actually models the X, Y, and Z coordinate in space of each one of those photographs. And we can use software programs to stitch those images together fairly efficiently into a measurable 3D model. So if there is a roof that's difficult to measure, there's a lot of obstructions, there might be trees in the area, photogrammetry can be very helpful. It can even measure things like topography and other terrain features for large ground mount structures. So I just wanted to give you guys kind of a little bit of an insight into that. So this is a real life example from a project of mine from last year. That is a 12-12 pitch roof, meaning 45-degree slope. That is very steep, difficult to climb on. Obviously, we have great installers who tie in and have various safety procedures from OSHA that they follow. But prior to the actual installation, we had to get physical measurements on site. And instead of climbing up on the roof and having one guy up on the roof trying to measure that, we actually used our drone to build a 3D model using photogrammetry and measure it all out to come up with a more finalized design. And you can see that this is a fairly photorealistic image of the home, which we can actually manipulate and turn in 3D space. So I'm a nerd, and I think that's self-evident. So we'll keep on going. This is the final design. A couple little changes. The customer actually redid their roof prior to the installation, and they took out one of the vents towards the top. So those top two modules are now kind of kissing. But aside from that, the design is the same. You can see the all black rails, the microinverters, the attachments, the guys tied in, and the final product. So I just wanted to give you guys an insight from beginning to end for that process as well. So what does an agricultural array look like? Ultimately, it looks like a solar system on a farm. That can be on the ground, like this example here. It could be much smaller than this. It could be up on the roof. So we'll show you a couple different examples. This is a larger system, high voltage. It was for a pretty big operation. So there is a fence around it due to the National Electric Code requirements on this one. You can see the modules do have spacing between them. They are fixed at a certain angle. And basically they have enough separation between them to minimize inter-row spacing, shading rather, from when the sun is lower in the sky in the winter. So we'll keep on going. This next one is for a hog farm. This was not one of my projects. The last one was not one of my projects, but they were all from our company. All of these systems were designed based off the needs of the client. So that's why there are a different number of panels or a different number of modules. In the industry, a lot of times we'll refer to solar panels as modules because they are modular, like Lego bricks. So you can add and subtract as needed. But I think that's a pretty nice looking system there. This one is one of mine, another hog farm out in Western Illinois, again, sized for the operation itself. Pretty nice long array, and it's a single phase service. So pretty simple installation all in all. So what are the financials and the incentives? These things can vary quite a bit based on which state you're in, based on what type of project it is, but we'll do our best to summarize it all. First and foremost, there is the federal tax credit. It was extended by President Biden recently to stay at 26% through the end of next year, so the end of 2022. And then it will drop down to 22% in 2023. And then it will go to 0 for residential systems, but it will stay at 10% at that time for commercial operations. So again, there is some variation between sectors. I am not a tax professional, have to tell you that legally. I cannot give you tax advice and I won't do that. So I can give you some of the high level details here, but you should always consult with a tax professional before making any investment like this. A tax credit is different than a deduction. A credit is not reducing your taxable income. It's reducing your tax liability. So a credit will go against what taxes you owe to the federal government. So again, you might need to work with your tax professional to figure out if and how you monetize that. A lot of times businesses, I've been told, can apply it over a 20-year period. For homes, I've been told it can be applied over a 2-year period. Aside from the tax credit, which is really a fantastic mechanism for recouping a portion of your project price, or investment rather, would be through maker's depreciation, which stands for Modified Accelerated Cost Recovery System, which is basically just a fancy way of saying accelerated depreciation. There was a change in the tax law where you can apparently take 100% bonus depreciation in 1 year. And as I understand it, you can also take it over a 5-year period. So again, you'll want to consult with a tax professional about all of this. but that is ultimately reducing your income, which ultimately, you would apply some sort of a benefit to that from a tax basis. So you can usually recoup somewhere in the 10 to maybe 20% cost range for an average commercial system. Additionally, there's the REAP grant, which is the Rural Energy for America program through the United States Department of Agriculture. We will talk about that more in detail. All right. So in addition to those tax benefits, there are state benefits for Illinois and Missouri customers as well. We service both those states, so we'll talk about each. On the Illinois side has a program called the Illinois Shines program, which is the brand name for the adjustable block program. Those are the same things. Essentially, what it is doing is it is paying you for 15 years of energy generation for renewable energy credits or solar renewable energy credits. And what those RECs or SRECs stand for, what they are is they represent the environmental benefit of that electricity. So again, you are getting paid for 15 years of energy generation based on the environmental value of that electricity that the system is going to generate. So obviously that will vary based on how big your system is and how productive it is. It also depends on where it's installed in the state and when you enter the program. Currently, when this was recorded today, the program is in a waiting period. Essentially, they've allocated a certain amount of funding into the adjustable block program. Each block has different SREC prices and a certain amount of fixed funding that was available for each block. As funding gets allocated and exhausted in each block, it moves to the next subsequent block, which is slightly lower value per REC, and then so on and so forth. At this moment in time, there has been more demand than the funding has supplied. As of yesterday, there were two bills that will likely address this concern. One is the Path to 100, and the other is the Clean Energy Jobs Act. So there are two bills that just passed out of committee yesterday, and hopefully, one of those bills or maybe a merging between those bills will pass in the spring. That's kind of what we're hoping for, which would in theory create another block of funding. Everybody who we're working with right now in the state of Illinois is choosing to work with us under the contingency that we are able to secure the next block of funding for their project. So with all that being said, this can be a pretty substantial value relative to the investment itself, which can cover maybe 30 to 40% of the project price. Again, it depends on system size, energy production, and all those sorts of things. On the Missouri side, it's substantially simpler. You have a certain wattage rating based off of the equipment. Every watt gets 25 cents. So very, very simple to calculate and to explain. The value is less attractive relative to the project price. So where you are making up for simplicity, you are losing value basically between these two programs. But having an incentive is obviously better than not having an incentive, and we will work with you to explain how all this works for your specific project. I hope that this was clear. It is a little bit more complicated than I'd like, but I hope this made sense, and we'll obviously work with you more to communicate further. So the REAP grant, this is pretty straightforward. The REAP grant is something that anybody in America can apply for as long as they are an agricultural producer where 50% or more of their income is coming from agricultural operations and 50% or more of their energy usage is going towards agricultural purposes. So if you meet those two criteria, you can apply for this grant. Excuse me. You can apply for this grant, and I have a grant writer who I work with who is really excellent to work with. He's super efficient. He knows the program very well. He helps people apply for this all over the country. He's actually helped, I think, 8 out of 8 clients that I've helped through this specific grant program get the grant. Essentially, it's a point-based system. So there are various things relative to your project that give you more points than others. And based on how much money you apply for and how the system is designed and all those things, you can try to leverage, the odds that you get the most possible points and get the grant awarded. It's not guaranteed by any means. Often there is a deduction for farmsteads because residential electricity usage is not, valid. It's not eligible to be applied towards. So if you're getting a system that's going to offset 100% of your electricity usage between your home and your business, and 20% of your energy usage goes to the home, 20% would basically be deemed ineligible. And you would only be applying for 25% of the remaining 80%. So again, all this stuff is very nuanced. That's why it's important for you to work with a professional like myself and our company. So we will walk you through this if it's applicable, and it can recover up to 25% of your project price. Again, I think it's more realistic to assume you're shooting for closer to 15% on average, but that's still substantial for sure. All right, so this is a quick testimonial from one of my clients who I've worked with in the past. He's a grain farmer in Central Illinois. He worked with us a few years ago, a really super nice guy. And this is about a 60 kilowatt system. So I'll let Riley click on the video and I will mute myself.
I decided to go solar because I was looking to come and move back to my family's farm and was trying to find ways that we could make that possible. And one of the ways to do that was by putting up solar, which I feel helps me as a farmer control the costs of my energy going into the future. I think solar is a good choice for farmers because it allows us to control something that's going to happen in the future. As we see energy prices rise, we can put up a solar array on our farms, use the sunlight, use our land, and ultimately be able to have a reduced or no electricity bill going into the future. Solar saves our operation money by eliminating an electric bill for us on our operation. We can continue to do everything here that we had before. Straight Up Solar helped us plan to get the right size of array for our business, and thus far we have not had an electricity bill to speak of since the solar panels came into production. A second way is Straight Up Solar helped us with a REAP grant from the United States Department of Agriculture. That helped to reduce our overall project cost and allowed us to shorten the payback period that we had for the solar array. And then the third one would be the SREC program that is part of the state's funding for solar projects. We receive a check every quarter after putting up and being approved for their program. So those are the 3 ways that we're able to save money on our operation by using solar. I would recommend Straight Up Solar to my friends and to people that I don't know because I just had a really good experience with the team at Straight Up Solar. The first contact that I had was with Andrew Stetter out of the Bloomington office. He's been my local contact and my local person that I go to with any questions. It's now been almost 2 years since we put up our project, and Andrew, if I have questions, is still good to pick up the phone, and then he's able to contact the team. And what I've found is that both in the office in Bloomington and in St. Louis have been very responsive to the questions or the problems that I've had, and they've done a really good job about rectifying those in a very timely manner.
All right. So I'm glad that we were able to get that testimonial video for you guys to check out. Ultimately, just a couple of anecdotal stories about working with Chris. We were looking at both roof mounts. You might have seen those 2 large machine sheds north of the array. We were also talking about a ground mount out to the northeast side of the property rather than the southwest where it was located. because it would have been closer to the utility meter. Chris decided that he wanted it on the ground, not on those roofs. And he really liked that location. So we ended up actually directionally drilling and boring underneath about 10 feet underground across the property diagonally to get over to the meter to cut costs and reduce the wire distance. And also avoid all the things that were in between, like the other structures. So just a couple of quick kind of notes about that project, but really proud of it. And Chris is a super nice guy, so I'm glad he was able to share his experience. Your experience going solar will be unique to you, and it will be unique to your property and your needs. So ultimately, for us to get started, we need to know your contact information. I can't really help you if I can't get a hold of you. I also can't really work on any sort of project design or pricing until I know where you live. So we'll ask for very basic information like who you are, how to reach you, where you live, and then for some energy information. So we know how much electricity you're using, what rate structure you're on, which utility you're connected to. So we know the rules that are associated with the utility and your jurisdiction. Ultimately, as a project developer, I'll do my best to size the system appropriately based off of the site information and also based off the information that you provide to me and your preferences, just like Chris had his own unique preferences. If we're able to design a system that is within your budget and something that you're happy with, and you decide to work with us, ultimately the project will move forward into the next phase where we start applying for the incentives, specifically the state incentive, potentially the REAP grant. And then we will have a project manager, a technician who will visit the site, an engineering staff who will get involved, permitting team. So we have this entire infrastructure of people on our team to help you for every aspect of the project. And then the installation itself typically will take a few days. It depends on the size and the scope of the installation. And then we will coordinate the interconnection with utility, as well as net metering and all those things. And then at that point, it's kind of set it and forget it. If you have any sort of issues, questions, or concerns, really do my best to retain as much of a relationship as I can with each one of my clients. So if you have somebody who you'd like to refer to us, you have a mechanism to do that. We do have a great referral program. Christopher himself has already gotten his neighbor, I think to the south of him, just went solar a few months ago. So we'll help you with that kind of stuff. If you have questions with monitoring portal, so you can kind of see what's going on with your system. If you have questions related to your net metering or your billing from the utility, we'll help make sense of that, as well as any other sort of issues you might have, whether it's servicing the system or not. So that's kind of the value that we bring to you, not just up till contract signature, but long into the ownership cycle of the system. So hopefully you have learned something today, and that you have better insight into what to expect. We hope that you will sign up for a free quote. Typically only takes about an hour to do a consultation, and it's totally free. It's a lot easier to make an informed decision once you have the information. So please let us get that to you for free. I don't know if there's any other slides in this slideshow. I think there are a few photos, so we'll show you those. Over on the left, these are all projects of mine. The one on the left is a triple black array split between two large structures in Goodfield, Illinois. It's a little bit over 600 modules, so close to 200 kilowatts. In the center there, that's out near Champaign, I believe in Monticello. Big FBI metal roof building there, and then a couple smaller ground mounts. The one at the top right is actually Chris's neighbors. So I mentioned that earlier. This is a pretty cool picture. It's a small system. It's about 6 kilowatts out in Scioto, Illinois, and just, really, really beautiful. Quick little note, nerdy note, but the reason why the sunset looks always red, orange, or yellow is actually because red, orange, and yellow are longer waves on the electromagnetic spectrum. So if you recall that rainbow of visible light, ROY, or red, orange, and yellow, are towards the 700 nanometer side of things, and BIV, or B for blue, indigo, and violet, are shorter on the spectrum. So those light waves actually get scattered in the atmosphere as the sun is setting. Obviously, the sun doesn't actually ever set. It just sets relative to where you are on the planet as the planet rotates. But as the sun appears to be setting based on your location, the light has to cut through more atmosphere, and those shorter wavelengths get scattered, giving us the sunrise and the sunset, actually. So quick note about that. And then this was Chris's neighbor. They were pretty happy with their system. Cute pup too. And then this is another cool project of mine. It looks like a big giant flat screen TV. Those triple black modules I think look great on the roof, and we got some cool drone shots of it, so we thought we'd show you. Another large farm project of mine up in Northern Illinois. It was, I think, about 60 kilowatts or so as well up on the roof. So he actually, this client has his father's array across the street, which was that really large ground mount with the grain bins on that REAP grant slide. So I helped develop this system. That other one was developed by my supervisor many years ago. So they're keeping it in the family. And, you know, again, this stuff really starts to spread as you go solar. It's very likely friends, family, neighbors, colleagues, and et cetera will be interested as well. So it's a really great opportunity to, you know, make an impact through a ripple. Big ground mount out in Monticello, actually, for a sex toy manufacturer. So really have helped pretty much everybody in all different fields go solar. Everybody needs electricity, so we hope that you'll go ahead and get yourself a free quote. And then this is one of the other hog farms that I helped develop out in Western Illinois a couple of years ago. Big, nice, long array parallel to the actual hog shed. And then this is my biggest project to date so far for Growmark, their operations facility or their distribution facility in Alpha, Illinois. Northwest of Peoria. So that's about 1,500 solar panels. See the car for scale on the right, and that actually on the left is not a drone that took that picture. That is from Google's satellite. So it's a few years ago, and Google's caught up to us. That's 100% offset for that big giant structure there. And then this is just a kind of blurry drone picture from a while ago for that system. You can see Riley and myself there kind of towards the center. So we hope that you were able to get something from this presentation, and you know, we really appreciate your time and your interest in solar. So thank you so much. Please feel free to reach out to me directly or go to our website and sign up for a free quote. And we hope to speak with you more in depth very soon.
Great. Thank you, Andrew, for taking us through that presentation. We're going to open it up to the Q&A session now. Just one more time, I want to point out that Andrew's contact information is here. You can reach Andrew by emailing andrew@straightupsolar.com. If you'd also like more information, you can go to our website, straightupsolar.com. Thank you.
Thanks so much.